Hi everybody, hope you're doing well. If you're watching this video, that means you're at the end of week 5 of the 4th marking period. This video is going to take you through the last of the factoring strategies that you need to learn, and it's going to deal with a strategy called grouping. You'll see as part of the problem, this references what are called cubic expressions because everything that you're going to see here does have x cubed in it, but that's not too big of a deal here. Ultimately, we're dealing with expressions that have 4 terms. So we've dealt with trinomials using that trial and error strategy. We've dealt with binomials where we had some GCFs and we did some difference of squares. Now we're looking at expressions with 4 terms. These have their own strategy, what we call grouping. So we're going to walk through that strategy here. There are 5 examples here that we're going to talk through and figure out how to factor these apart. Again, this is the last of the strategies here, and then the next couple of lessons after this, we are going to go ahead and put everything together in terms of factoring and solving completely. So, if you were given a 4-term expression, so what's called a quadrinomial, and you're told to factor it, here are the 3 steps as you can see up above. So they give you a sample expression here, x cubed plus 5x squared plus 8x plus 40. What you do is you group the 4 terms into 2 smaller groups. So you can see the first 2 terms get put in parentheses, and same with the second 2 terms. Now, we're not going to distribute them and multiply them together and come up with this crazy problem. What we're doing is, in each of those groups, we're going to find the GCF. So you can see the first group of x cubed plus 5x squared, the GCF is an x squared. Take that out, show that what's left over with the x plus 5. You look at the second group, positive 8x plus 40, you take out positive 8, you're left with x plus 5. Now you can see a very important note underneath when you do this. So again, we've done GCFs before, now we go back to using it here for this strategy, which is actually kind of nice because it reviews some older stuff. The goal in this is to get common factors, aka when you pull out the GCFs, you better have the same stuff left over. And if you've done this right, that'll be the case every single time. So you can see when we pull out our GCFs, we have x plus 5 left over each time. That is an awesome thing. That means we've done this correct. So what we do here is get our final answer from 2 places. We get it from the common factor, and then our second factor comes from the GCFs we pulled out. So it doesn't matter technically. I know it says write the common factor, then write the GCFs you pulled out. It doesn't matter which order you put the factors in, like we've talked about with the other strategies, but that's where you get your final answer from. The x plus 5, which was in common, the x squared plus 8, the GCFs that you pulled out. It's going to be the same process for all of these problems here. So let's take a look here at how we do this. So let's take a look at number 1. X cubed plus 7x squared plus 2x plus 14. 4 terms. We're going to go ahead and put parentheses. We're going to group them. First 2 terms go together, last 2 terms. I would make sure whatever sign is in front of that third term, make sure that's included in your parentheses. That'll be especially important when that third term's a negative. That's going to make, we want to make sure that our GCFs are pulled out correctly. So whatever sign, make sure it's grouped in, as you can see with what I've written now. So let's look at group number 1. Group number 1, I want to find the GCF. So the biggest thing I could take out of x cubed and 7x squared is an x squared. What's left over? X cubed divided by x squared is x. 7x squared divided by x squared is 7. So that's, in the first group, me taking out the GCF. Now I'm going to look at the second group and do the same thing. What's the greatest thing I can take out? I can take out a positive 2. Now, if it's positive, I'm going to write a plus sign with it because it'll make sure what we write here at the end will have the correct signs. If I take a 2 out, 2x divided by 2 is x, 14 divided by 2 is positive 7. Again, the biggest clue that you will have done this correctly is that these leftover factors match, and they have to exactly match. The signs can't be different. I guess that would be about the only thing that would maybe possibly lead you down the wrong path, but they have to exactly match. In this case, they're both x plus 7. That's awesome. Our final answer comes from the common factor, x plus 7, and the GCFs we pulled out get magically put together as a factor, and your final answer is x plus 7 times x squared, plus 2. So let's go ahead and try it with the second example. So again, I'm going to group the first two, then group the second two. So I look at group 1 here, 3x cubed plus 21x squared. What is the GCF? Biggest thing I can take out, 3x squared. What's left over? 3x cubed divided by 3x squared, just an x, because 3 divided by 3 cancels. 21x squared divided by 3x squared, 21 divided by 3 is 7. X squared divided by x squared, cancels. So there's my first group, all factored apart. Second group, same deal. What can I take out? I could take out a positive 5. Do the division, I'm left with x plus 7. My common factor of x plus 7 matches. That means I can go ahead and get to my final answer. Final answer against the common factor x plus 7 times the GCFs I have left over, make a factor, 3x squared plus 5. With grouping, that's pretty much the nuts and bolts of it. Now, we'll see here, not everything's always going to be plus signs, but you can see it's going to be the same pattern here with not only these first couple here, but again, as we move forward, if you've got 4 terms, this is exactly what you have to do. All right, so let's look at number 3 and number 4. Again, if you think you've got a pretty good grip on this, feel free, try them. If you get what I get, awesome. If you don't, pay attention to the explanations. So, number 3, group your terms. Let's look at the first group. Biggest thing I can take out is an x squared, and I'm left with x minus 6 when I divide that away. Now you'll notice the second group. You see a leading negative, so it's negative 4x plus 24. I would say 99.999 times out of 100, if the leading coefficient is negative, take the negative out with it. So the fact that there is a negative 4x plus 24. So if you're just looking at the values, yeah, you could divide a 4 out of both things. But the fact that the 4x, the leading term here, is negative, take a negative 4 with it. Here's the reason why. If I divide a negative 4 out of both terms, negative 4x divided by negative 4, the negative 4s would cancel and you're left with just x. 24 divided by negative 4 is negative 6. If I took out a positive 4, I'd have negative x plus 6. That wouldn't match. But now you see that I have x minus 6 as that match. It has to be an exact match. It can't be close. It has to be exactly the same. And since they do, we've got ourselves a correct factor in here. So, x minus 6 would be one of our factors, and x squared minus 4 would be one of our factors. And that would be my answer. Now, technically, this is a problem that will go further, but we will talk about that in the next lesson here, how to factor completely, because if you actually can break this down a little bit further with one of the factors, but just for the sake of what we're doing here, we're going to limit the math that we're going to do with this. But for right now, those are your 2 factors. That's going to be your answer. All right, number 4 here, same deal. Group them. Your first group, biggest thing you can divide out, 3x squared. You cannot take a 6 out of both because 21 is not divisible by 6. You have to have whole numbers. You can't, or integers I should say. You can't have decimals here. That makes it just a little bit harder to work with. So we're going to stick with integers only. If I take a 3x squared, divide out of both terms, I'm left with 2x plus 7. Looking at the second group, 12x plus 42. The biggest thing I can take out is a 6. And if I do that, I've got myself 2x plus 7 when I divide 6 away from both of those terms. Again, that's great. My common factor is 2x plus 7. With my GCFs, I have 3x squared plus 6. And again, this is one of those where you might look at this and go, and some of you might recognize that this can actually factor a tiny bit further, but again, we'll emphasize that more next week. That's going to be our final answer for now. So again, with this grouping strategy, in short, split the problem into 2 sets of 2 terms, find the GCF of each of those groups. If you do it correctly, you'll get those matching pieces, and that'll allow you to figure out your final factored answer. So number 5, haven't seen one of these probably in a while, little describe and correct. This was left in from the original notes, and I figured I'd just keep it in so we could talk through what it might be a common mistake. So you see the original problem, you see the work. Again, great place, I think. Hit the pause button and see if you can figure out in your head what's wrong with it. Here's what's wrong with it. So my original process would be take the original problem, split it apart, 2 by 2. If I look how the first group is factored apart, you should take out an x squared. If I divide that away, you're left with x plus 8. Awesome. If you look at the second group, you should be taking out a negative 6. They took out a positive 6 and still magically ended up with x plus 8. That's not correct. That doesn't work. This needs to be a minus 6 taken out. Otherwise, you can't get the x plus 8 that's there. So the error is we took out the wrong GCF. Of the second group. So let's go ahead and fix it. So it'd be x squared with the x plus 8 minus 6 times x plus 8. Now, you notice the final answer here, it's not going to be that hugely different, but there is a big difference between x squared plus 6 and x squared minus 6. Okay, so signs are important, as you very well know, but your final answer should be x plus 8 times x squared minus 6, not x squared plus 6. There is a difference with that. That does have a different meaning if we were to do other math with it. So, again, just kind of to show you, again, watch your signs. If you have that leading negative, make sure the negative comes out with whatever you're finding as your GCF. So, that's how we factor by grouping, and again, you'll only use this strategy with 4 terms. It's the last of the strategies that you're going to learn here in Algebra 1. There are other factoring strategies that do exist. You'll learn about them next year in Algebra 2, and certainly also be emphasizing a lot of these different factoring strategies that you've learned already with those as well. So, but that's down the road. With this, there will be great assignment posted with it. Again, pretty short, because again, not a lot to do with this strategy here. It's kind of the same pattern over and over again, kind of like the difference of squares. So again, make sure you complete that, submit that in a timely manner. Obviously, if you have any questions how to do this, send me a Schoology message, shoot me an email, or stop by my office hours on Zoom. I will be happy to help you. Otherwise, stay safe, stay healthy, and as always, thank you for watching.